All right, so we're going to learn how to how to divide polynomials. We know how to factor, certainly degree 2, trinomials. We know how to factor difference of squares, which might be higher degree. We know how to common factor, but we may need to divide by some binomial factors. So first thing to help us is I want you to do that question, first one, long division, back to elementary school. Okay, see if you can remember showing your work how to long divide. Show each step. Hopefully you remember at least how to set it up. Okay, so you're yes. I want you to, because it's going to help you with doing it algebraically. Yeah, you should know the answer, but let's do it long division to show the steps. So 20, how many times does it go into 30 approximately? One time. Then you multiply back, that's 20. Subtract, you get 10. Bring down the next number. How many times does 20 go into 103? Approximately 5 times. 5 times 20 is 100. Subtract, you get 3. Okay, so if you were to rewrite this, so this is equal to 15 plus 3/20, right? In terms of your quotient plus your remainder divided by the divisor. Really with numbers, that's the same as 15 and 3/20, a mixed fraction, okay? So take a look at that form and look at how results when we have variables, how it's going to look. So your P here is 303 in terms of the number question. This is 20. Quotient is 15, whatever you get at the top there. Plus the remainder is 3 over the divisor is 20. Those are both the same. How can you get back to the original 303? Well, that's actually kind of like converting a mixed number back to an entire improper fraction. You multiply the divisor by the quotient, so 15 times 20 plus 3 gives you 303, the original, right? So 303 is 20 times the quotient plus the remainder, okay? So that's comparing it to a number question, a rationals question. We want to be able to do it with binomials, trinomials, any kind of polynomial, okay? Now, in regular math 30-1, we'll keep it into just dividing by x minus a, but you're in IB, so we will look at some where we might have a coefficient in front of x in a few minutes. So, what we do here, divisor goes outside just like a number, polynomial goes inside just like the numerator. You get your quotient and your remainder, okay? And then from there, you can show it in these forms. So for this particular one here, well, I've already labeled them, but the divisor is 20, polynomial is equivalent to 303, quotient is 15, and remainder is 3. Okay, but let's do it with some polynomials. So long division, how does it compare? Set it up the same way. Your divisor is in the denominator there. Okay, your numerator is your original polynomial that you're dividing by x plus 2. Sometimes, like these are shown as fractions, sometimes we'll just use the division symbol. Okay, so now we only look at the first term. So first term is x. This first term is x squared. So x squared divided by x is x. That's what goes up top. Now, when I do this, I actually like to line up the x terms, but it doesn't matter where you put them. So just like we did with the number question, once we figured out approximately how many times, then we multiply this back with the divisor. So what's x times x plus 2? It's x squared plus 2x. Line underneath, subtracting, but you're subtracting the whole thing. So I like to put brackets around it so that I don't forget that I'm subtracting everything. If you've chosen this number or term correctly, these should go to 0. Okay? Now think about in your head what's negative 5x minus positive 2x. Well, that's going to be negative 7x. So you subtract, then you bring down the next term, just like you brought down the next digit. Okay, now you look at how many times does 7 go into negative 7x? Negative 7 times. Okay, then multiply that back. Negative 7 times x is negative 7x. Negative 7 times 2 is negative 14. Okay, this is where people mess up on the signs. So then you're subtracting everything that you just entered there. So negative 7 subtract a negative 7 goes away. If you've chosen it properly, the first term should go to 0. Then 7 minus negative 14 is like adding 14, so that's 21. Nothing more to bring down, so you're done. Okay, it says write your results in this form. So this equals the quotient, which is x minus 7, plus the remainder over the divisor, which is x plus 2. Okay. You can even put brackets around that to remind yourself that that is the quotient. So it really gives you a rational expression. Back from Math 10. Okay. Now, if you had thought, oh, maybe I could factor and divide out x plus 2, if you had that expression back in Math 10 when you did rationals, you would have just left it because you can't factor that numerator, right? So you would have just left it, not know what to do. Now you can, now you've learned how you can divide it. When is this helpful? It's not always helpful, but it is, what's really helpful is for these types of expressions that you don't know how to factor, and if you divide by x minus 1 and there's no remainder, then you know you have one of the factors, okay? And you can, so it will help you to be able to divide higher degree polynomials. We're starting out with pretty straightforward ones, just degree 2. So now do the next one. Oh, this is the same question. Oh, this is synthetic, right, yeah, sorry. We're going to do long division underneath here first and then go to synthetic. So let's go underneath. You can leave that as is. Sorry, I thought they were lined up the other way. Okay, so if I take a look at this, I've written it just like I did the previous one, but take a look at all the terms. I've got an x cubed now, an x squared, and no x term. So everything that I do needs to be lined up when you subtract them. So I'm actually going to move this minus 6. Now you can leave it like that, or what I like to do is enter in a 0x. So it's like a placeholder. 0x is just 0, but it's where x's will show up so that hopefully you don't just skip over it or add terms that aren't like terms or something like that. So if there's a term missing, put a space or 0x or whatever term is missing there. Okay, so now do the next. First term, x cubed divided by x is x squared. Multiply that out. Then you're subtracting everything there. So if you've done it correctly, this should go to 0. Okay, so you don't even put 0, just leave it. 3x squared minus negative x squared is like adding x squared, so that's going to be 4x squared. And then you bring down the 0x, that placeholder. Okay, so then 4x squared divided by x is 4x. Multiply that through. Chosen it correctly. Those go to 0. So then 0 minus a negative is like adding, so that's 4x. And then 4x divided by x is 4. Okay, so now your remainder is negative 2. Okay. So when you show it, this is equal to your quotient. Okay. Actually, I'm going to move this down a little bit. Okay. Plus your remainder, which is a negative. So actually, I can show this as a minus here. Minus 2 over x minus 1. Okay, so, yes? If there's a remainder, then you leave it. If there's no remainder, then yeah, you're going to end up factoring. So that one I would just leave. Even though you can factor that, you just leave it because there's a remainder, so it's not going to help you at all. So this is long division. Takes a bit of time writing out all those terms and x's and all that kind of stuff. So there's a method that's faster. Okay, you still have to show some work, but this is acceptable to use this faster method called synthetic division. So you are allowed to use the fast way. So what is it? So synthetic means kind of fake. Well, it's not fake. You still get the right answer, right? But this is what I'm going to do with this one. So I'm going to leave the x plus 2 there that I had. And now my division symbol is going to go the other way. Okay, so I'm going to go down like this. But kind of make it, if you've got lined paper, then make this on one line, and so this is your line of your paper. So it's kind of a big L going over 2 lines. Okay. So I put the x plus 2, that divisor, out. You don't have to. You can just put the 2. Okay, but I put that to remind myself because there are 2 versions of synthetic division. And so you don't want to get mixed up which is which. So I put that out because that's like the regular question. Then no matter what version I'm just going to erase the dots here. You put in just the coefficients of the polynomials. So 1, -5, and 7. So it's saving you that time of putting in all all the x's. And you'll see in some notebooks or some textbooks a line kind of at the bottom here to separate the remainder. Yeah? Yeah, so we'll do that in the next one. Exactly. You'll put a 0 as a placeholder. So now, kind of like what we did there, you'll take a look. Whatever the coefficient of the first term is what the coefficient on your quotient is going to be, right? X was 1 there, 1 there. Here this was, oh, actually that was a 1 as well. But even in these, when we got down to 4x squared and 4x, it's the same. So here, we're just going to bring down the 1. You don't have to do a thing. You copy down that first coefficient. Then, just like you do in long division, you multiply back. Okay, but you're just going to multiply it by that constant term. So 1 times 2 is 2, and it goes into the next column. Okay. Then, just like we did there, we subtract. So negative 5 minus 2 is negative 7. Then we multiply back by the 2, so that's negative 14, and it goes into the next column. Then we subtract. 7 minus negative 14 is 21. Okay. Same remainder as we got in the first one. A whole lot less work to get there. Okay. So what did we do? We used the constant term of that divisor, bring down the first term of your polynomial, and you multiply each to go in the next column and subtract. Just like long division. The alternative that some textbooks or some other teachers at different schools might use is putting here the x value that makes that 0, which would be negative 2, so opposite sign, multiplying through and adding each row. But we're going to keep it like our long division. So it was with, I think all of us do it this way. Okay, so how do you interpret this in getting your answer in the correct form? So this is equal to, well, what's your quotient? So looking at this, if you started with an x squared, then this is going to be the next degree lower. So this is going to be x. Next degree lower is a constant, so that's x minus 7. 1x minus 7. Then plus your remainder, this is always your remainder, 21, over that divisor. Okay. So don't just leave it. You still have to put it back into the polynomial form, because this is really meaningless, but you are allowed to use this as a method on tests, etc. You continue on to calculus, which if you're an ID, you will, then you'll do this a fair bit, actually. Okay, so next one, x minus 1. Then coefficients here. So 1, 3, and we have to put a 0 in, and then negative 6. You have to have that place value. And so that last column will end up giving you your divisor. You bring down the 1. 1 times negative 1 is negative 1. It goes in the next column. And you're subtracting. I'll put it there to remind yourself. Okay? So 3 minus negative 1 is 4. Multiply back, that's negative 4. It goes in the next column. 0 minus negative 4 is positive 4. Multiply back is negative 4. Negative 6 minus negative 4 is negative 2. Okay. So, How does that relate? Well, our original polynomial was x cubed, so this will be the x squared term. So x squared plus 4x plus 4, then minus 2 is the remainder over the divisor. Okay, a lot faster than long division. Okay, so before we get into the remainder, actually, let's do the remainder theorem. We'll do a little bit more complicated ones in a bit. So let's go to the next page. Okay, so you do this one on your own. This is synthetic division. Okay, set that up. Okay, so there's your synthetic division. It's not asking you for the quotient, so you don't have to write it out. It's saying use synthetic division to determine the remainder. This is your remainder. Okay. Next thing is determine the value of f of 2. So that means you substitute 2 in for every x. Okay. You can enter that in your calculator if you want. Of course, 24 plus 20 plus 12 minus 4. Oh, equals 52. That's weird. Not weird, but it is right now for you. So if f of 2, is f of 2 equal to the remainder from part A? Yes. Is this a coincidence? Let's check with another example. So good practice for synthetic division. So do the next one. Careful on this. There's no x squared term. Okay, so put a 0 placeholder. Okay, so when you use synthetic division, you get a remainder of negative 130, and then I want you to find the value of g of negative 3. So that's going to be negative 27 times 4 is negative 108. Okay. Is it? No. 25 times 4 is 100. Minus 15 minus 7 equals negative 130. Okay, so that's the same. So yes. Okay, so how are these related? So the number that we're asking you to substitute in to the polynomial function is the value of x that makes the divisor 0. Okay, so we were dividing by x plus 3. We asked you to substitute in negative 3. You got the same remainder. Here, dividing by x minus 2. What value of x makes that 0? Positive 2. When you put it in, you get the remainder. So that's the relationship. The remainder will be the same if you substitute in the value of x that makes that binomial 0. So when a polynomial is divided by x minus a, the remainder is equal to f of a. So this makes things even faster than synthetic division. If all I'm asking for is the remainder, you just substitute that value of x, which is a, in, and you get the remainder. So long division is the longest way, then synthetic, and then the substitution is the fastest way to get the remainder. Now, sometimes we will have to use synthetic, or you can use long if you wanted to do more work as we learn more. Factoring, for example, solving polynomial equations. But just for remainder, this is it. Okay, so in other words, the remainder when f of x is divided by x minus a can be determined by evaluating the polynomial function at x equals a. Likewise, f of a can be determined by finding the remainder, so it goes both ways. It's a biconditional statement, if you remember back to when f of x is divided by x minus a. So here, that's one way of writing the results of a polynomial division that we talked about. So since we're going to show it in the form of the divisor being x minus a, then there's your divisor, x minus a. When we substitute that a value in, we see that that factor goes to 0, so you get 0 plus the remainder. So this is a sort of a little proof for you. Okay. All right, so it says write a conclusion given the following statements. So what can you conclude from this? When g of x is divided by x plus 5, the remainder is negative 12. So to summarize that, g of negative 5 will equal negative 12. Vice versa from that, if we know p of 6 is equal to negative 17, then when p of x is divided by x minus 6, the remainder is negative 17. Okay? So either way. Okay, so I'm going to leave this one, same deal. You can do this to check. So this is very much like questions 1 and 2. So you can do that on your own in a bit. Let's look at the next page. These are the ones that are a little bit more challenging. Okay, so when p of x is divided by x minus 1, the remainder is given to you, 7. Determine the remainder when p of x is divided by x plus 2. Well, problem is we don't know all the coefficients, right? So we don't know what k is. So you can't just substitute negative 2 in there and get the remainder because you have a k. But you're told the remainder here, so you can solve for k and then use it. So the first statement, okay, so that means that p of 1 equals 7. So from this first sentence, okay, value of x that makes x minus 1 0 is 1. When you substitute it in, you get 7. So that means 1 cubed plus k times 1 squared plus 2 times 1 plus 9 equals 7. So you can solve that for k. Ones are nice, right? So that's 1 plus k plus 2 plus 9 equals 7. So 10, 12, k equals negative 5. So now we know what p of x is. So therefore, p of x is x cubed minus 5x squared plus 2x plus 9. So to get the remainder will be equal to p of negative 2, right? Value of x that makes that 0. So negative 2 cubed minus 5 times negative 2 squared plus 2 times negative 2 plus 9. Didn't use any synthetic division. Okay, we use what's called the remainder theorem. 32. Okay, same deal. Next one, you don't know all the coefficients. Now we actually don't know two of them. But we are told when it's divided by x minus 1, we get a remainder of 4. And when it's divided by x minus 2, we get a remainder of 21. So we have two situations, which if you think about it, will help us. Back here, we were given one situation, and we had one unknown here, okay, but one equation, so we could solve for k. Here we'll have an equation in terms of k and p for the first part, and then another equation in terms of k and p for the second part. So that's a system. Back to math 10, where you can solve that system of equations. Okay, so g of 1 is going to be equal to 4. So what's g of 1? K times 1 cubed plus p times 1 squared minus 1 plus 3. Okay, then g of 2 will give us 21. So then that's going to be k times 2 cubed plus p times 2 squared minus 2 plus 3 equals 21. So simplify both of those. Get it down to a's and p's. And then solve the system. So I just got variables on one side, constant on the right. I noticed here that I could divide everything by, that would make it easier for solving. So substitution or elimination, totally up to you. I'm going to eliminate p myself, right, because they have the same coefficient now. So the p's will go away, maybe. K minus 2k is negative k. 2 minus 5 is negative 3. And then substitute back in. 3 plus p equals 2. So p equals negative 1. Okay? We just asked for what k and p are, but I would actually put it back in to your g of x. Always show your final equation with all the variables or coefficients in there. So k is 3. P is negative 1. Minus x plus. Okay. So I want to do a couple more, a little bit more challenging synthetic division so that you understand how it works for other binomials. So what I want to go through is synthetic division if you're dividing by ax plus b, something like that. So if we have, let's say, this polynomial. And I'm going to show it this way because sometimes we might show it like this rather than in fraction form. So you can do it long division, and it's no different from long division. Set that up front. How many times does 2x go into 8x cubed? 4x squared times, etc. But for synthetic, we put this out front here and enter in our values, 8, 6, -3, -1. Then if we bring down the 8 and multiply just by the constant, it's not going to work out. Thinking about, well, if we were doing the remainder theorem, we would actually substitute in 1/2, right? So what do we do here? Easiest way, or what I do, is I think about, okay, I'm going to divide by the coefficient of x there. So that will give me x minus 1/2. Okay? I never leave it like that, but I do it for my synthetic. Okay? And then we're still going to show that 2x minus 1 is our divisor. Okay? Then I use this when I'm doing my synthetic division. So 8 times -1/2 is -4. Subtract, I get 10. 10 times -1/2 is -5. Subtract, I get 2. 2 times -1/2 is -1. Subtract, this one I actually get 0. Okay, so that means there's no remainder. Okay, now look at it. I got 8. That would be x squared, 10x, and 2. So really, if I were to show it as p of x equals d of x, q of x plus remainder, right? There's no remainder here, right? So this polynomial function is equal to, so if I'm writing this out, this is a good way of letting you see. Here, my divisor now is x minus 1/2. My quotient here is now 8x squared plus 10x plus 2. What don't I like about that? What will Ms. McKay get annoyed with and maybe take marks off? Yeah, so it's not completely factored on the right-hand side. What about the first factor? What don't I like about that first factor there? Do we ever factor and have fractions? No. So when we factor, we don't have fractions. So remember that these are related, right? So if I factored out a 2 here, just like you said, it wasn't completely factored. So if I factored out a 2 here and multiplied that 2 back into the first bracket, I'll get 2x minus 1, and I'll have 4x squared plus 5x plus 1. That's the form that I want. Okay? So, do you have to show it like this and then like this? No. If you've done your synthetic here, you should think, okay, I divided by 2 and use that number, but I still want the 2x minus 1 as a factor. So I'm going to then divide everything by that coefficient, that 2 that I divided there. So then it'll be this as my factor and whatever I get there after I divided by 2. So you don't have to go and show that step. This is how you understand how it works. Okay, but that you don't have to do all of that. Okay, similarly, if there was a remainder, say there was a remainder here, say it was 5. Well, then there would be a 5 here. That dividing by 2 has nothing to do. I don't double this or anything, right? Because it's divisor times the quotient plus the remainder. And this is all in one term here. Okay. So, let's get you to do one more here. So I'll just set it up. So this is number 2, and let's go 3x minus 1. Sorry, I'm trying to make this up on the top of my head. Give me 1 second. Okay, so well, let's just do that. I'll try it. Okay, so do that one. Okay, so then I'm going to divide by 3, because that's what I divided by there. And then that's going to be 2x minus 3, and then plus your remainder. Always check your work. So let's check it. 6x squared, got it, minus 9x minus 2x is negative, oh, what did I do wrong? Did I get that wrong? Oh, that's a plus. 2x plus 3, right? Because that's a positive there, sorry. So 6x squared plus 9x minus 2x is 7x. Minus 3 plus 7 is 4. Yeah, sorry, I don't know what the minus is. Okay. And then the last thing to note is if you're dividing by, say I have some polynomial divided by x squared plus 2. Okay? Well, x squared plus 2 is a binomial, but it's not a degree 1 binomial. So synthetic only is good for x minus something, for ax minus b, like degree 1 divisors. This, you have to use long division, okay, if you were at something like that. So just be aware, synthetic is good only for linear divisors. All right, so that's where I'll stop it.